So this video is going to be about formation reactions, maybe, if it wants to write. Yes. Formation. So really there is 5 different types of reactions, and I'm going to make a video for each one, but 5 types of reactions. The very first one is formation. It's supposed to be the simplest one, and it is just an element plus another element, and that makes a compound. So first we should talk about what an element is and what a compound is. So something like sodium all by itself would be an element. Notice it doesn't have a charge, it doesn't have a positive or a negative on it, right? That makes it an element. It's something all by itself, uncombined with anything else. Chlorine is also an element, but chlorine is what we call a diatomic element. So when it happens in twos, and so it has to happen like so. So both of these are elements, but this one is a special one called a diatomic element. It is important that you know the list of diatomic elements, so make sure that you memorize that list of diatomic elements, which is hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine, phosphorus, which happens actually in 4s, and sulfur, which happens in 8s. You must memorize this list. These are called diatomic elements. They're things that happen in 2s when they are by themselves. They don't like to be by themselves. Now when this combines, so when sodium and chlorine combine, they're going to make what's called a compound. The compound is going to be something that is a combination of the sodium and the chlorine. So to figure out what the combination is and what the formula for that is, you would, on your table of ions, look up what the charge for sodium is, which was positive, and you would look up what the charge for chlorine is, which is negative. What that means is that sodium is going to lose 1 electron, and chlorine is going to gain 1 electron. Because they're going to lose and gain exactly the same amount, they cancel each other off, and we just simply write NaCl. And again, when I write NaCl, there should be no charge on it. It should be no positives or negatives. It should just say NaCl. Okay, the other important part of writing out reactions is that we obey what's called the law of conservation of energy. Or mass, sorry, conservation of mass. All that means is that whatever I started with should be what I ended with. So underneath each, I should have a list. Let's see if I can move it a little bit. So underneath each, or even to the side of each, I should have a list where I'm kind of doing what's called chemistry bookkeeping. So my list is going to be NaCl, and over here it's also going to be NaCl. So over here I'm going to count, and by the way, these things over here are called the reactants. These things on this side of the arrow are called the products. These are called the reactants because they are reacting together. These are called the products because I am producing them. So if I count how many sodiums there are 1 sodium. If I count how many chlorines there are, this little 2 tells me that I have 2 of them. Over here I have 1 sodium and 1 chlorine. Okay, so 1 sodium, 1 chlorine. I need the lists to be the same. So they have to, you can't magically create sodium and you can't magically create chlorine, so they have to be exactly the same. So because I have a 2 over here, I want this one to also be a 2. So in order to conserve the mass, I'm going to put a 2 in front of here. Now here's an important point, is that you can never write subscripts into it to make it balanced, so I can't put like a 2 here, for instance. That is a no-no, so you can't put a 2 there. That doesn't happen. You can only put coefficients in front, so only numbers in front. So by doing that, now I have changed this to 2 chlorines. So now I have changed this to 2 chlorines. But notice that putting the 2 in front is just like math. I changed also not only the chlorines, but the amount of sodiums to 2. So my lists still don't really match, right? Because over here I have 2 sodiums and 2 chlorines, and over here I only have 1 sodium and 2 chlorines. So in order to make it match, I'm going to put a 2 in front of the sodium here as a coefficient, and therefore now it becomes balanced. So we're going to try some more too. So I'll get a brand new page here. So this is another example of a formation reaction. So the question might read something like calcium and oxygen react, write out the reaction. So as soon as I see the word calcium and oxygen and they're reacting, that means that the calcium and the oxygen are on this side. And then this is an element, not combined with anything else. This is an element, not combined with anything else. And they are going to make a compound. So I find the symbol for calcium. Again, no charges on it, no positives or negatives, because it is an element. It does not have a charge. Oxygen is one of those ones from the previous page where I said you have to memorize the diatomic list, so it should be O2. And then to figure out what the compound is that I make, I'm going to have to look up that calcium is 2 positive on my table of ions. Oxygen is 2 negative. Because this one is 2 positive, this one is 2 negative, they cancel each other off, and I simply just write CaO, which is calcium oxide. So calcium oxide. You'll notice that the first name stays exactly as you find it on the table of elements. The second one, the ending usually changes to IDE. There is some exceptions to that, but right now, for easy sake, we'll just say that you change the ending to IDE. You can also just look on the table of ions for the ending, but you will see that it's there. Okay, now we need to do the chemistry bookkeeping. So now we need to do the chemistry bookkeeping, so you need to make sure that you have the same amount on each side. So I'm going to write CaO underneath each side. Over here I have 1 calcium, over here I have 2 oxygens, over here I have 1 calcium, over here I have 1 oxygen. Again, I need my list to be the same, right? So to get the 2 oxygens here, I'm going to put a 2 in front of here. Remember again that you can only write coefficients, not subscripts. So a 2 in front of here. Now this did change this, but it also changed this. So now this is also a 2. So that means that I need to put a 2 in front of here to also have the same. Okay, let's try a harder one. How about sodium reacts with phosphorus. So sodium reacts with phosphorus. Now you have to remember that this is one of those ones from that diatomic list, so it actually happens in 4s, so you should have a 4 here. Okay, so this is the sodium, an element. This is the phosphorus, which is an element. And they are going to combine or react, because they are reactants, to make a compound, right? So on my scrap paper, I'm going to look up what sodium is, that its charge is positive. I'm going to look up what phosphorus is, that its charge is 3 negative. So that when I make the compound, the 3 goes down here. So I get Na3P, like so. Remember that this part here is scrap paper. I don't want to see that, right? I don't want to see any charges up here. It should just be Na3P. Now it's a matter of getting it to balance. So I just want to show you that if I write my list underneath of stuff that I need on each side, and I start counting, over here I have on the reactant side 1 sodium, over here I have 4 phosphorus, over here I have 3 sodium, and I have 1 phosphorus. Okay, the numbers are not even. So if I just went by my list and I started with the sodium, I could put that, hey, I need a 3 in front of here, and that changes this to 3. It's a good idea to do this in pencil, because what I see now is that when I go on to phosphorus, phosphorus needs a 4, right? So that means that here I need to put a 4 in order for this to become 4 here. So now I have 4 phosphorus, but this also changed this, right? Now I have 12 sodium. So that means that my first number of putting 3 here does not work, and I would actually have to change it to 12. So that comes with time and practice, and you learn over a while which ones you should start with, but that's one. And I'm going to do one more. So the next one I'm going to do, or the last one, is nitrogen reacts with hydrogen. So nitrogen is N2, hydrogen is H2, and what they make when they go together, I'm going to tell you even that in this case it produces ammonia. So you would have to know what ammonia was. Remember that that was one of those ones that I said you should memorize, but you could also look it up in the data booklet. It should be somewhere. Okay, so when they go together, now it's a matter of balancing. So I wanted to do this one for balancing. Notice that this is a 2 and this is a 2 because these are diatomic molecules, right? So this means I have 2 nitrogens and 2 hydrogens. This means I have 1 nitrogen, and this means I have 3 hydrogens. So in order to balance it, what I'm going to have to do is I'm going to have to, first off, I would probably maybe say, oh, well, I need to start with nitrogen and make it 2 and put this in front of here. And that works, right? But then it changes the hydrogen also. So just make sure that you're looking for those things, because that changed to 6. So that means now that I need to put a 3 in front of here, so that 3 times 2 gives me the 6 that I need also. Okay, so good luck with the simple formation reactions or formation reactions. Try a whole bunch of examples so that you can keep practicing.